Welcome guys to my new video. In this video we will talk about all the computer basics. We will learn all about desktop, motherboard, the system numbers, and all the computer basics. So first of all, like my video, subscribe to my channel, and let's start our video. First, what is the word informatic? The word informatic is a compound word. It consists of two words, information and automatic. In fact, we took the first five letters of the word information and combined them with the last 7 letters of the word automatic. The informatics mean the science of the automatic computer processing. This is what means the word informatic in computer science. Now, what is a computer? The word computer was created in 1955 with the objective of automatically processing information, meaning it can execute any algorithm provided in the form of a program. It can manipulate, store, encode, and communicate information, including text, image, video, file, etc. And these are the 3 definitions of a computer. A computer is an electronic machine. Why the computer is an electronic machine? Because it is made with the electronic component like the motherboard, the screen, keyboard, etc. The computer is an automatic machine because it operates and performs tasks with minimal human. The computer also is a programmable machine because the computer cannot carry out any work task without using programs, which will determine the action to be carried out. This is what it means, the word computer. So it's very important to memorize. The computer is an electronic machine, is an automatic machine, and is a programmable machine. Now let's see what is a computer system in computer science. The computer system is a set of integrated hardware and software components that work together to perform specific tasks of set of tasks. It includes things like the computer itself, the printer, scanner, the hardware part, and the program that are used to integrate with all. Programs like the Microsoft Office, Linux, etc. Here we have 2 examples about the computer system. First example is a personal computer or the PC. It's a computer system that is designed for individual use. For example, I have a personal computer or the PC. My brother have a PC, etc. It's an individual use. Second example is a server. A server is a computer system that is designed to provide a service to other computers on a network. Now, what is a mainframe? A mainframe is a large, powerful computer system that is used to process large amounts of data. The mainframe are a data server designed to process up to 1 trillion web transactions daily with a high level of security. The mainframe are a high performance computer with a large amount of memory and data processors that process a billion of simple calculations and transactions in real time. These CPUs can execute a billion of instructions per second. Now, what is the memory? The mainframe is a memory also. The mainframe computer typically have a large amount of memory ranging from 100 of gigabytes to terabytes. The storage, mainframe computer typically have a large amount of storage ranging from terabytes to petabytes. This storage is used to store data that is not currently being used by the CPU, such as the database, the file, and the application. The application and the file that the user don't use it. Now let's talk about the part of the computer. The computer has two parts, the hardware and the software. What is the difference between hardware and software? The hardware is all the physical part of the computer, like the screen, keyboard, speaker, a motherboard, etc. But the software, it's all the applications and the software like the Microsoft, Linux of the computer. The software is all the application. This part cannot be touched by the human. This is the difference between the hardware and the software. Now let's start talking about the hardware. The hardware refers to the set of physical elements that make up a computer and allows it to function. The hardware components are the physical part of the computer that you can touch it, such as the processor, memory, and storage devices. These components are responsible of data processing, information storage, and display the result, and program execution. Now let's talk about the main hardware component of a computer, and let's start with the input and output device. The computer accepts data from some source, such as user, program, etc., which are called the input devices. The computer may be required to display the result of its processing. For example, the result may appear as text, number, image, or a graphic on the computer screen, or a sound from the speaker. The computer also can be sent output to a printer or to transfer the output to another computer through a network or the internet. The output is an optional step in the information processing cycle, but may be ordered by the user program. Okay, the difference between the input and output device is the input device are used to enter the data into the computer by using the keyboard, for example, but the output devices is used to display the data or the information on the screen, for example, or on the speaker if I need to listen to a music. This is the difference between the input and the output device in the computer. Second, the central processing unit, or the CPU, or also its name processor. The CPU is the brain of the computer. It's responsible for processing all the data that the computer receives that come from a user, for example, or a software. Third, memory. Memory is where the computer stores data that is currently being used. There are two types of memory. First type is the random access memory, or DRAM, and second type is the storage memory. Now, what is a RAM, or the random access memory? The random access memory is a volatile memory where the program execution takes place. The RAM is a type of memory that is used to store data that is currently being used by the CPU. It is called random access because the CPU can access any data in RAM at any time. RAM is a volatile memory, which means that it loses its content when the power is turned off. This is because RAM is powered by the computer's power supply. When a program is executed, the CPU loads the program code into RAM. The CPU then executes the program code one instruction at a time. The data that the program needs to execute is also stored in RAM. Okay, the RAM is a volatile memory, it loses all the information of or the content when the computer is turned off, because the RAM is worked by the computer's power supply. Now and finally, let's talk about the storage device. Storage device is used to store data that is not currently being used, such as programs, file, document, etc. There are two types of storage: internal storage and external storage. The internal storage is located on the computer itself, but the external storage is located on devices that are connected to the computer, like the USB, the SD card, and the external hard disk. This is the five hardware components of a computer. Now let's talk about the software, and let's see the difference between the software and the hardware. The software it is what allows the computer to perform tasks such as running programs, accessing data, and display information. The software part is the instructions that tell the hardware what to do. Now, the software part of a computer can be divided into two main categories. First, the system storage and the application storage software. First, the system software. The system software is responsible for managing the hardware and providing basic functionality to the computer. The system software can be the operating system, device driver, and other system software in a computer. Now let's talk about the application software. The application software includes the Microsoft Office, Adobe Photoshop, Google Chrome, etc. The software part of a computer is essential for its operations. Without software, the hardware would be useless. Software is constantly evolving. New software is being developed all the time, and existing software is being updated to add in new features and improve performance. Now, this is the difference between the system software and the application software. Now let's talk about the operating system. Operating system is a software that schedules tasks, manages storage, and handles communication with other devices, like the Windows, Linux, and Mac OS. The software installation. How to install a software? Software can be installed on a specific computer or device, on a network, or accessed via the cloud. Now, why we use the software or the application, for example? We use the software for the communication and social networking. For example, if I need to talk about my friends, my family, we can send an email or a message on Facebook, WhatsApp, etc. The social networking, and to know all the news from the world. We can use also the application or the software if I need to design, photo editing, make a video, create a video, etc. And we have also the mobile application, like the games, etc. This mobile application can be installed on a tablet, a smartphone, and etc. This is all about the software and the hardware and the difference between them. Primary partition. Primary partitions are the most important partitions on a disk. They can be used to store the operating system, applications, and data. A disk can have up to 4 primary partitions. A primary partitions can be boot partitions, which mean that the computer can start up from them. To make a partition, primary partition, you need to install the operating system on it. Now let's see some benefits of using the primary partitions. First, they are more reliable than the logical partitions. They are easier to manage and troubleshoot, and they can be used to boot the computer. The primary partitions are a good choice for storing the operating system and other important files. However, it is important to back up your data regularly, and you have two primary partitions, one of the operating system and one for the private data. You can only have 4 primary partitions on a disk. If I need to format one or a part of these partitions, you are erasing all the data on this part, and the other data on the other parts is not affected. When you're formatting a part, you are erasing all the data that on this part. However, the data on the other parts is not affected. Your data on the second partition will stay the same when you format and reinstall the operating system on the first partition. This is because the second part is separated from the first partition and is not affected by formatting the first partition. It's always a good idea to back up your data before you make any change to your computer. This is because there is always the possibility to lose all your data on your computer. This is all about why we use the primary partition. Here are some tips for backing up your data. 1. Back up your data regularly. This means backing up your data on a regular basis, such as once a day or once a week. Back up your data to multiple locations. This means, for example, on a cloud storage, USB, DVD, or a hard disk, etc. And 3, test your backups. This means testing your backup to make sure that they are working properly, and then you can restore your data from them if you need. This is some tips for backing up your data. It's very important to make backup on your phone, laptop, to not lose your data. Now let's talk about the extended partition and see what is an extended partition and what is the difference between the primary partitions and the extended partitions. The extended partitions is a special type of partition that contain multiple logical drives. Logical drives are essentially partitions within the extended partition. When you format the partition where the operating system is, you are only erasing the data on the partition. The extended partition and the logical drives within it will not be affected. This is what is the extended partition. And the difference between the extended and the primary is when I need to format the partition, the extended partition is not be affected. It is important to note that the new operating system may not be able to access the extended partition or the logical drives. This is because the new operating system may not recognize the file system that is being used on the extended partition. Here we have some tips to protecting your data. Back up your data to an external hard drive like a USB or a hard disk or a DVD. Create a system image of your computer. This will create a backup of your entire operating system and your data. Use an antivirus program to protect your computer from a virus. This is some tip to protecting your data, and back up your data is very important. In the primary partition, you have only 4 partitions on a hard disk, on the disk, but in the extended partition, we have multiple partition on a disk. A primary partition is a partition that can be booted from. This is mean that the computer can start up from it. Primary partition can also be used to store data, but it is not necessary. In the extended partition, it allows you to have more than 4 partitions on a disk. This can be useful if you need to separate your data into different partitions. A shrink volume is a process of reducing the size of partition. This can be useful for creating a new partition or for freeing up space on an existing partition. You can install the operating system on a shrink volume, but there are a few things to keep in mind. 1. The shrink volume must be large enough to hold the operating system and all of its necessary files. The shrink volume must be formatted with the correct file system. The operating system installation process with usual format the shrink volume for you. 3. The type format for a shrink volume is NTFS. The NTFS is the default file system for the Windows operating system and is the most compatible file system for shrink volume. The NTFS is a more efficient file system than FAT32 and exFAT, and it supports features such as files and disk and user permission. To shrink a volume, you need to right-click on the volume you want to shrink and select Shrink Volume. Then enter the amount of space you want to shrink the volume by and right-click on Shrink. Now the disk management tool will create a new unallocated space that you can use to create a new partition or to extend an existing partition. This is all about the extended partition, and this is the difference between the primary and the extended partition on your computer. And I repeat, it's very important to protect our data and to make backup, for example, every day on one time on a week. Now let's talk about the operating system. An operating system acts as an interface between the software and the different part of the computer or the computer hardware. The operating system is designed in such a way that it can manage the overall source and operations of the computer. Operating system is a fully integrated set of specialized programs that handle the operating system of the computer. It controls and monitors the execution of all other programs that reside in the computer, which also include the application, program, and other system software. The operating system can be Windows. The Windows is an operating system. Linux is an operating system, and the Mac OS is also an operating system. It is a collection of a software that manages computer hardware, resource, and provides common service for computer programs. The operating system is the most important type of the system software in a computer system. The operating system helps in improving the computer software as well as hardware. Without the operating system, it becomes very difficult for any application to be user-friendly. The operating system comes with a large number of device drives that make the operating system service reachable to the hardware environment. And finally, the operating system helps an application with the hardware part without knowing about the actual hardware configuration. It is one of the most important parts of the system and hence present in every device. Present in every device. If the device is a large or a small device, the operating system help the hardware to work. Now let's talk about the function of the operating system. One, the resource management. The operating system manages and allocates memory, CPU time, and other hardware resources among the various programs and processes running on the computer. Two, process management. The operating system is responsible for starting, stopping, and managing processes and programs. It also controls the scheduling of processes and allocates resources to them. 3. Memory management. The operating system manages the computer's primary memory and provides mechanisms for optimizing memory usage. 4. The security. The operating system provides a secure environment for the user and applications and data by implementing security policies and mechanisms such as access controls and encryption. 5. Job accounting. It keeps track of time and resources used by the various jobs or user. 6. The file management. The operating system is responsible for organizing and managing the file system, including the creation, deletion, and the manipulation of files and directories. 7. The device management. The operating system manages input and output devices such as a printer, keyboard, mouse, etc. It provides the necessary drivers and interface to enable communication between the devices and the computer. 8. Networking. The operating system provides networking capability such as establishing and managing network connections, handling network protocol, and sharing resources such as printers and files over the network. Now let's see notes about the operating system. 1. The operating system enables multiple users to share computer system and its resources simultaneously by providing time sharing that allocate resources fairly and efficiently. The operating system provides a set of system calls that enable applications to interact with the operating system and access its source. System calls provides a standardized interface between application and operating system, enabling portability and compatibility across different hardware and software platforms. Now the objectives of the operating system is to user-friendly, easy accesses, and management of resources and controls and monitors, and share the result easier. This is all about the operating system in our computer. It's very important to know that the operating system it can be Microsoft, Linux, or the Mac OS. Exercise 1. What is the difference between the primary partition and the extended partition? The extended partition is a partition that contains multiple logical drives, but a primary partition is a partition that can be boot partitions, which means that the computer can start up for them. And the primary partition have four partitions on a disk, but the extended partition have a multiple partitions on a disk. And now let's see the answer. And a primary partition is a type of the disk partition that can be hosted in operating system and be marked as active. But an extended partition is a special type of primary partition that can contain multiple logical partitions, allowing for more than 4 partitions on a disk. This is what is the difference between the primary and the extended partition. Exercise 2. Is the operating system a hardware part? The operating system help the hardware part on the computer to work. Let's see the result. No, an operating system is not a hardware part, it is a software. The operating system acts as an intermediary between the hardware and the user, managing hardware resource and providing the service for the computer programs. This is what the definition, a small definition about the operating system. What is a desktop case? A computer case for any type of computer is sometimes called the chassis and house of the power supply, motherboard, processor, memory modules, hard drive, and other drives. A computer case can be a tower case, a desktop case that lies flat on a disk, an all-in-one case used with an all-in-one computer, or a mobile case used with laptops and tablets. A computer case lies flat and sometimes serves double duty as a monitor stand. Now let's see the ports used with a desktop case and mobile computers. First, let's start with the VGA. VGA is the Video Graphic Array port. Is used as a female port that transmits the analog video. We all see this, the VGA in our desktop computer. Second, the S-Video port. The S-Video port is a 4-pin or 7-pin round video port sometimes used to connect to a television. The 7-pin port is shown on the left. The 4-pin port is missing the extra pins in the middle and is the more common type. Now, a DVI or the digital video interface port, it transmits a digital or analog video. It's supporting the input and the output devices. This is the DVI or the digital video interface. Now, an HDMI or the high definition multimedia interface. It's a port that transmits a digital video and audio and is often used to connect to home theater equipment. This is the HDMI. And we have also the display port, like this. It transmits digital video and audio and is slowly replacing the VGA and the DVI ports on personal computer. Now, the Thunderbolt port, it transmits video, data, and power on the same port and cable and is popular with the Apple computer. The port is shaped the same as the display port and is compatible with DisplayPort devices. This is the Thunderbolt port. It's used with the Apple computer. Now the network port is used by a network cable to connect the wired network. This is the network port. Now the audio port, like this. This is the audio port, also called the sound port. Is used for the microphone, the audio in, the audio out, stereo, and etc. This type of audio port can transmit analog or digital data. If you have one audio cable to connect to a speaker or earbuds, plug it into the lime green sound port in the middle of the three ports. The microphone used the pink port. The green port is for the audio cable, and the pink port, this is used for the microphone. This is the audio ports. Also, we all see this audio port in our computer. Now let's talk about the SPDIF, or the Sony Philips Digital Interface. Also, it's a sound port. It's connected to an external home theater audio system, providing digital audio output and the best signal quality. When connected to a fiber optic cable, the port is called an optical connector. This is the SPDIF, or the Sony Philips Digital Interface, the sound port. Now the USB, or the Universal Serial Bus Port, is a multi-purpose input and output port that comes in several sizes and is used by many different devices, including printer, mice, keyboard, scanner, external hard drives, and flash drives. Some USB ports are faster than others. This is the USB port. Now the FireWire port, also called an IEEE 1394 port, is used to high-speed multimedia devices such as a digital camcorder. Now look at the external SATA, or the eSATA port. Is used by an external hard drive or other device using the eSATA interface. The eSATA is faster than the FireWire. Now the PS2 port is a round 6-pin port used by keyboard and mouse. The ports look alike but are not interchangeable. This is the PS2 port. An older serial port, sometimes called DB9 port, is a 9-pin male port used on the older computers. It has been mostly replaced by the USB ports. You will see a serial port on a router, for example, where the port is used to connect the router to a device. A technician can be used to monitor and manage the router. This is the serial port. Now the parallel port, like this, also called LPT port, is a 25-pin male port used by the older printers. This older port has been replaced by the USB port also. And finally, the modem port is used to connect the dial-up phone lines computers to a computer. A modem port looks like the network port but is not a white. This is all about the port that will this port is in the computer case. You can see this port in the computer case. Now let's talk about what we have inside the desktop case. Inside the desktop case we have the power supply. This is the power supply. We have also the optical DVD and CD drive. We have also the power cord. We have the processor. This is the processor. And we have two hard drive and the motherboard, the front of case, the memory. This is the memory slots, and the SATA data cable. This is the STA data cable in red. This is what we have inside the desktop case. Now let's talk about the motherboard. The motherboard, also called the main board or the system board or the MOBO, is the largest and most important circuit board in the computer. The motherboard contains a socket to hold the processor or the CPU. The central processing unit or the CPU, also called the processor or the microprocessor, does most of the processing of the data and instructions for the entire system. Because the CPU generates heat, a fan and heat sink might be installed on top to keep it cool. A heat sink consists of the metal fins that draw heat away from a component. The fan and heat sink together are called the processor cooler. This is the motherboard in our computer, and this is the part of the motherboard. It contains the CPU, the the memories, it contains the CPI slot, etc. This is the motherboard. Now the expansion card. A motherboard has an expansion slots to be used by the expansion card. An expansion card, also called an adapter card, is a circuit board that provides more ports than those provided by the motherboard. This is the expansion card. And this is the port of the expansion card. Now the memory modules. A desktop motherboard has memory slots called DIMM or the dual inline memory module slots to hold memory modules. The memory, also called RAM or the random access memory, is temporary storage for the data and instructions as they are being processed by the CPU. The video card also contains some RAM chips for the video memory. Let's see the memory in our computer. We have the one installed DIMM. This is in green, and the three empty DIMM slots. This one in blue, in black, and another in blue. This is the memory in our computer. Now the hard drives and other drives. A system might have one or more hard drives, an Octal drive, a tape drive, or for a really old system, a floppy drive. A hard drive, also called a hard disk drive or HDD, is permanent storage used to hold data and programs. For example, the Windows 8 operating system and the application are installed on the hard drive. All drives in the system are installed in a stock of drive base at the front of the case. Each drive has two connections for cable. The power cable connects to the power supply, and another cable used for data and instructions connect to the motherboard. This is all about the hard drive. Now the power supply. A computer power supply, also known as a power supply unit or the PSU, is a box installed in a corner of the computer case that receives and converts the house current so that components inside the case and used. This is the power supply in our computer. We can all see the power supply in the computer case. If you open the computer case, you can see it. The power cable can connect to and supply power to the motherboard, expansion card, and drives. This is the power supply in our computer and why it's important. The most power supplies have a dual voltage selector that switch on the back of the computer case, like this. Dual voltage selector switch. This is in red. Now let's talk about the ATX form factor. ATS, or the Advanced Technology Extended, is the most commonly used form factor today. It is a non-proprietary industry, originally developed by the Intel in 1995 and has undergone several revisions since then. The original ATX form factor for cases and case fan blowing the air into the case, but early revisions to the form factor had fans blowing air out of the case. Blowing air out of the case does a better job to keep the system cool. This is the importance of the ATX form. And this is the ATX form in our computer. Now let's see the power supply connectors. And let's start with the 20-pin P1 connector. It's the mainboard power connector used in the early ATX systems. This is the 20-pin P1 connector. To the 24-pin P1 connector, also called the 20 plus 4-pin connector, is the mainboard power connector used today. The 20 plus 4-pin P1 connector has 4 pins removed, so the connector can fit into a 20-pin P1 motherboard connector. Now the 4-pin 12-volt connector is an auxiliary motherboard connector, which is used for the extra 12-volt power to the processor. This is the 8-pin 12-volt connector, is an auxiliary motherboard connector, which is used for the extra 12-volt power to the processor, providing more power than the older 4-pin auxiliary connector. And this is also the 4-pin Molex connector, is used for older IDE drives and some newer SATA drives. It can provide 5-volt and 12-volt to the drive. Now the 15-pin STA power connector is used for STA drives. It can provide plus 3.3 volt, plus 5 volt, and plus 12 volt, although plus 3.3 is seldom used. Now the 4-pin Birch connector is used by the older floppy disk drive FDD. And this is the PCIe, or the 6-pin connector, provides an extra plus 12 volt for the high-end video cards using the PCI Express or the version 1 standard. This is in the red is the PCIe 8-pin connectors, provides an extra plus 12 volt for the high-end video card using the PCI Express version 2. This is the version 1 and this is the version 2. The version 1 have 6-pin and the version 2 have 8-pin. Now the PCIe 6 and 8-pin connector is used by the high-end video card using the PCIe times 16 slots to provide extra voltage to the card and can accommodate a 6-hole or 8-hole port. To get the 8-pin connector, combine both the 6-pin and the 2-pin connectors. This is all about the power supply connectors in our computer case. Now let's talk about the John von Neumann architecture. What is the John von Neumann architecture? The von Neumann architecture is a standard architecture that can be found in our computer today. It was invented by the mathematician John von Neumann and represents a major milestone in the history of computing. It is based on the fundamental concept that data and programs should be stored in the same memory, meaning a shared memory that contains both code and data. At the end of 1945, John von Neumann proposed the stored program concept and the construction of the electronic discrete variable automatic computer as a model machine of the computer. The electronic discrete variable automatic computer was a binary computer rather than decimal and was stored program computer. Finally, John von Neumann proposed to store both program and data together in one memory. This is the architecture of the John von Neumann. This is the architecture of the John von Neumann and how it works. The program is a sequence of instructions provided to the computer for an eventual execution by the processor. The processor here, it contains the control unit and the arithmetic logical unit. The role of the processor is to extract the instructions from the memory one by one, to interpret them and to execute them until the problem is solved. The instructions transferred is made through bus. First, let's talk about the arithmetic logical unit. ALU is a logic unit. It performs mathematical operation like the addition, multiplication, the division, and logic operation, for example, equal and or not equal, for example, requested by the program. The control unit, CU, it interprets the instructions in memory and causes them to be executed. The memory, it stores both data, variables, and the program. And the input-output operator, it allows the computer to communicate and interact with the outside. For example, the keyboard, I enter the data by the keyboard. It's an input. Output, the computer print the data on the screen, for example. The keyboard and mouse is input variable and the screen is an output. This is how the John von Neumann architecture works. Now let's go to talk about the arithmetic logical unit, LAU. The arithmetic logical and logic operator unit, LAU, is a component of a computer that is responsible for performing basic operations. These operations include arithmetic operation like the addition, multiplication, and division, as well as logic operator. For example, a calculator is capable for performing an arithmetic and logical operator. The ALU is like a calculator for a computer, as it can carry out the necessary arithmetic and logical operations to execute a program. This is what the arithmetic logic unit, it's important for the computer. It's like a calculator for the computer. The ALU is the computer unit that is responsible for performing calculations. It is integrated into the CPU. It means the microprocessor. Now the control unit, or CU. Control unit determine the order in which the instructions of a program should be executed and control the retrieval of the proper operands. It governs the flow information through the system by issuing control signals to different components. The control unit is a component of a computer responsible for the sequencing of operations. The CU is in charge of reading instructions from the currently executing program and transmitting this instruction to other computer components. The control unit operates by following a set of predefined instructions known as sequencer. The sequencer is a table that instructs the CU on which instruction should be executed at each step of the program. The CU also uses an instruction register to store the instruction currently being executed, which contains the memory address of the instruction. The CU is an essential component of any computer. Without the CU, the other computer components should not be able to function in coordinated manner. This is the architecture of the control unit and how it works. In the CPU, it gives the command to the ALU, and the ALU gives the result to the memory, and the memory gives the data to the arithmetic logical unit. The control unit gives the command to the memory, and the memory gives the instructions to the control unit. This is how it works, and this is what is the control unit in our program. Now let's talk about the important part of our computer, the CPU. The CPU is the abbreviation of the Central Processing Unit, commonly called processor. The CPU is the brain of the computer where most calculations take place. This is the CPU that can be found in our computer. It is the unit that performs the program processing stored in the main memory inside the computer. CPU has two components, the arithmetic logical unit, ALU, which performs arithmetic and logic operator, and the control unit, which extracts instructions from memory and execute them, calling on the ALU when necessary. The processor has two components, the arithmetic and logical operator and the control unit. The CPU also contains very fast and small memories called registers. A register may hold an instruction, a storage address, any kind of data, or temporary result. This is the importance of the CPU in our computer, and this is what is the CPU. It's a very important processor in our computer. Without CPU, the computer doesn't work because the CPU is the brain of our computer. Now let's go talk about the diagram detailing the different elements of the John von Neumann architecture. This is the diagram of the John von Neumann architecture. We have here the central process unit. In the central process unit, we have the control unit, arithmetic logical unit, and the register. And here we have the memory unit. Here we have the input device and the output device. In the register, we have the PC, CIR, AC, MAR, and MDR. Now let's see what is the AC. AC, the accumulator, is a temporary memory used to store data during processing in the computer. Stores intermediate arithmetic and logical results. The PC, or the program counter, keeps track of the memory address of the next instruction to be executed. It essentially points to the location in the memory where the CPU should fetch the next instruction. MAR, or the memory address, holds the address of the memory location to read from or write to in our computer's memory. CIR, current instruction register, holds the currently executing instruction in a computer center processing unit CPU. The MDR, or the memory data register, temporarily stores data fetched from or to be written to the computer's memory. This is the different part of the registers in the CPU. The memory is a component of a computer responsible for storing data and programs. Data consists of raw information such as numbers, letter, image, music, audio, etc. Programs are sets of instructions that guide the computer on how to perform tasks. The RAM, the memory has two types. We have the RAM, or the random access memory, and ROM, the read-only memory. The RAM in the computer working memory used to store data and performs currently is used. The RAM is a volatile memory, meaning it loses its contents when the computer is powered off. But the ROM in the computer performs memory. It's the permanent memory, stores programs necessary for the computer's startup and operation. This is the difference between the RAM and ROM. The memory is a component of a computer responsible for storing data and programs. We have two types of memory: random access memory RAM and read-only memory ROM. Now let's talk about the main memory, or the RAM. This is the RAM. You can find this also in our computer, laptops, and etc. The main memory RAM, or the main memory, is called random access memory. Is the area in the computer that stores programs and data of quick access by the processor, the CPU. In addition, it can manipulate only data that is main memory. Therefore, every program you execute must be copied from a storage device into the main memory. Everything in the memory is stored in binary. The computer works in the binary 0 and 1. The RAM is a volatile memory, meaning it loses its contents when the computer is powered off. This is all the definition about the RAM and what is the important about the RAM. Now let's go talk about the ROM, or the read-only memory. Is a non-volatile memory, which means it retains its content even when the computer is turned off. The RAM, the content it loses when I turned off the laptop. As for the memory that contains both data and the currently running program, it's known as random access memory. RAM is used to store the data and the program currently is executed. Now the bus. In computer architecture, a computer bus is a communication system that transfers data between components inside a computer. A bus consists of a set of words that carry binary signals. There are three types of a bus: a data bus for the data transfer, the address bus for the address transfer, and a control bus to the control signal transfer, such as read from the memory. This is the bus and the importance of the bus in our computer. Now the input and output unit. The input and output unit are devices that allow the computer system to communicate and interact with the outside world and to store information. Let's start with the input unit. It brings information into the computer that will be coded and later on processed by the CPU. For example, of the input unit, we have the keyboard, mouse, scanner, webcam, microphone, camera, touchpad, pen, the input, electronic whiteboard, the card reader, the CD, sensor, and etc. But the output unit are devices that bring information out of a computer after being processed. For example, we have the monitor, printer, screen, speaker, and the LCD projection panels. Some devices called input-output devices provide both input and output of data, such as a hard disk, the pads, modem, touch screen, audio sound card, and the network card. This is the difference between the input and output units in our program. And now let's talk about the hard disk, HDD. This is the hard disk, can be found in our computer also. The hard disk is an electronic data storage device that is used magnetic storage to store and related digital information using one or more rigid repeatedly rotation disks or platter coated with a magnetic metal. The platers are paired with the magnetic heads, usually arranged on a moving actuator, which read and write data to the plater surface. Data is accessed in random access manner, meaning that individual blocks of data can be stored. The HDD are a type of non-volatile storage, retaining stored data even when the power off. This is all about the hard disk, the HDD, and the importance of the HDD in our computer. A database. A database is a collection of data that is organized so that it can be easily accessed, managed, and updated. For example, of data applications include computerized library system, flight reservation system, and many content management systems that store websites as collections of web page in a database. Database offer many benefits, such as reducing the amount of time spent adding, deleting, changing, updating, for example. And the data in database is typically stored in tables, which are made up of rows and columns. Each row in a table represents a single record, and each column represents a single piece of information about that record. The column can be, for example, the ID of a person, the name and username of a person, book. For example, if I need to put the information about a book, the name of the book, and this is the introduction or the definition of database. So, in computer science, we study the database for understanding the essential in the field of computer science and information management. Now let's talk about the data. What is a data? The data in computer can be numbers, word, file, image, music, audio, video. This is the data. We will explore different types of data and see how the database can handle them. And now let's talk about the Database Management System, DBMS. The Database Management System is a computer software that enables you to create, query, update, delete the database, and managing the content of the database. It's mean to access, create, read, select, or update, for example, and delete the data referred to CRUD operations, and the access to these data in the database. This is the definition of the database management system. It helps us to create, to update, delete the database and managing the content of the database. The SGBD also allows defining some constraints on the data called integrity constraints, defining data access and security, passwords for example, and providing data recovery backups. The BDMS interacts with the user, other applications, and the database itself to capture and analyze the data. This is the importance of the SGBD. Some of the well-known BDMS include the Microsoft Access, MySQL, Microsoft SQL, Oracle, and the Sybase and IBM DB2. Most BDMS are based on a client service model. In this model, the database is stored on a server that is only used for that database and to interact with the database. A software called client is installed on a computer, the service, and get the answer from it. We have here database, the data, we have the service, and we have a client. There are many types of BDMS. They range from small systems that run on a personal computer like the laptops to huge systems that run on a mainframe. Mainframe are a computers that support hundreds of users. The BDMS are often classified according to the database model that they support. The most popular database systems since the 1920s have all supported the relational model as represented by the structured query language, the SQL. We will talk about this language in this video. The SQL, it's the magic language of database, and it's so important in database. Now let's talk about the most important part of the database, the structured query language, SQL. SQL, it's the magic language of the database. SQL is a language that allows communicating with the database. This language is widely used by the web developers to communicate with the data of a website. It enables selecting, answering, updating, deleting the data from a database. SQL can also be used to manage database. It's meant to create, to delete, or update the database. This is the importance of this language, SQL, in database. SQL is a special language designed to communicate with the database. With SQL, we can ask questions and add new data, delete the data, or even update the data. Now let's see the basic SQL command. We will learn basic SQL commands such as select, to obtain the information, insert, to add new data, update to modify existing data, and delete to delete the data. This is the SQL command that we use in database. What is a table? Now that we know how to talk our database with SQL, let's explore the concept of a table. A table is like a magical spreadsheet that organizes our data into row and column. Each table has a specific purpose, such as a contact list or a book catalog. Now, the column and row. In a table, the column represents the different categories of information, like the name, ID, age, etc. The row contains specific records with that information. Think of a table as a magic grid where each box has specific value. The table is the most common and simplest form of data storage in a relational database. A file is a column in a table, that is designed to maintain specific information about every record in the table. The record, also called a row of a data, is each individual entry that exists in a table. And the column is a vertical entity in a table that contains all information associated with a specific file in a table, like the age, the name, the ID, the username of a person, and other informations. The primary key. What is a primary key in a table? A primary key is a unique identifier for each record in a database table. It serves as a fundamental concept in relational database, ensuring that each row in a table can be uniquely identified by one or more of its attributes. The primary key is uniqueness. Each value in the primary key columns must be unique across all the records in the table. This ensures that no two records have the same identifier. The primary key is no nullability. A primary key column cannot contain null values. Every record in the table must have a valid and unique identifier. This is what is the primary key and the importance of the primary key in the table and database. Now let's talk about the foreign key. It is a primary key are often used in a relationship between tables. When a column in one table refers to the primary key of another table, it becomes a foreign key, establishing a link between the two tables. Now let's talk about the types of database relationship. We have three types: one-to-one relationship, one-to-many relationship, and many-to-many relationship. Let's see the difference between these three types, and let's start with the one-to-one. One-to-one relationship exists when each record in a table A is related to only one record in table B, and vice versa. For example, a table of a customer can be linked to a table of a shipping address. Each customer has a unique shipping address, and each shipping address belongs to a single customer. This is the one-to-one. Let's talk about one-to-many. One-to-many relationship exists when the record in table A can be linked to multiple records in table B, but each record in table B is linked to only one record in table A. For example, an order table can be linked to a customer table. Each order is placed by a unique customer, but each customer can have multiple orders. This is the difference between one-to-one and one-to-many. Many-to-many exists when a record in a table A can be related to multiple records in table B and vice versa. In this case, it is necessary to create a joint table to connect the two tables. For example, a product table can be linked to an order table. Each order can contain several products, and each product can be presented in server order. This is the three types of relationship in a database table. Look at these examples. In the first table, we have table A and table B. The table A, we have capital ID and capital name. And the second table, table B, we have country ID, name, capital ID. This is an example for the one-to-one relationship. One, here we have one column, two, one column in table B. A to B, one-to-one. But here in the second example, table A and table B, it's one to many because we have one column in table A is related to many columns in table B. This is the difference between these relationships. What is a computer network? A computer network is a set of connected computers that are computers and hardware devices such as printer, modem, router, hub, that are linked together via cable or wirelessly like the Bluetooth and Wi-Fi. These connected computers and devices can communicate with each other and exchange data, voice, video, image, and can share resources like the access to the internet and the printers, file services, and others. The computer networks offer also other benefits such as increasing storage capacity so you can access files and multimedia like images, music, videos, and stored on remote machine, improving communication between people via emails or chat, facilitating many types of games and entertainment that can be played by multiplayers on local network or online, like the online game like PUBG and Uno that you can play with your friends online. A computer network is a collection of interconnected computers and other computing equipment that communicate with each other to share resources and exchange informations. Computer networks can be of different sizes, ranging from a simple home network to a large global network like the internet. It's used at the computer network is used at home, university, school, for example, in a company. This is all about the definition of the computer network. Let's talk now about the computer or the network equipment, and let's start with the network card. The Network Interface Card (NIC) is a network card installed in a computer server or network device that allow you to connect to a computer network. It is the most important component. It is responsible for transmitting and receiving data over the network, as well as managing the MAC and IP addresses associated with the computer or device or the It may enable a wired connection or a wireless connection to a local area network. This is the network card. Now the hub or the concentrator. A hub is used to connect multiple devices together within a local area network, LAN. The hub contains multiple ports. When a packet arrives to a one port, it is copied to the other port so that all segments of the LAN can see all packets. Now the switch. The switch is a computer networking device that connected devices together on a computer network by using packet switching to receive, process, and forward data to the destination device. The switches are commonly used in local area networks and can vary in size and complexity depending on a network needed. Now the router. The router is a network device that connects computers and network to the internet or other networks. The main role of the router is to forward data packets between different networks using the best possible route to reach their destination. This is the router. A router is a network device that helps connect networks and devices together and transfer data between them using the best possible path. It analyzes data destination addresses and uses routing a table to determine how to route data to its destination. Now the repeater. The repeater is it reserve and retransmit incoming electrical, wireless, or optical signals. Repeaters attempt to preserve signal integrity and extend the distance other reach which data can safely travel. This is the network equipment. The network card, hub, switch, router, and the repeater. Now let's talk about the computer network types. We have three main types of computer networks. The local area network, LAN, metropolitan area network, MAN, wide area network, WAN. This is the three types of computer network. Let's start with the local area network. The local area network is a network that connects computer and devices in a limited geographical area such as home and office building. For the network transmission speed in between 10 megabytes to 1 gigabyte. The network capacity does not exceed it's 2 for 100 computers or 2 to 1000 computers. This is about the local area network. Now let's talk about the metropolitan area network. It's a large computer network that usually spans a city or a large campus. It is the union of several local area network within the same perimeter of a very large company, region, or a city that connects computers within 10 to 25 kilometers. The metropolitan area network usually use a fiber optic. For example, a university or a college can have a MAN that connects the several local area network located in an area of 1 kilometer. This is the difference between the local area and the metropolitan area network. Now let's talk about the wide area network. A wide area network is a computer network that covers a large geographic area such as a city, country, spans even interconnection distances. It uses communication channels that combines many types of media such as telephone line, cables, airwave. The largest, the WAN, is the internet. This is the importance of the wide area network. Now let's talk about the network topology. Computer network topology is how nodes like computers, equipment, devices, etc. are connected to each other on the network. The topology determines how data is transferred across the network and how nodes communicate with each other. There are several types of network topologies, each with their own advantage and disadvantage, like the bus. The network topology includes bus, tree, ring, and star. Let's start with the bus topology. In the bus topology, like this, each node is connected to a single cable. A signal travels in both directions to all machines connected on the bus cable. The bus transmits data from one to other nodes. This is how the bus topology works. Now let's talk about the ring topology. A ring topology is a bus topology in a closed loop. Data travels around in one direction. When one node sends data to other node, the data passes through each intermediate node on the ring until it reaches its destination. The nodes are connected in a loop and with the data flowing in one direction. This is how the ring topology works also. The star topology. It's like a star. We have here a server or a hub, for example. Each network host is connected to a central hub with a point-to-point connection. The hub represents a single point of failure. All nodes are connected to a central point like a switch or a hub here that transmits data from one node to another. Now the hierarchical topology. The network is divided into levels. The top level is connected to a server low level. The node can't themselves be connected to a server low level node rather than linking hubs or switch together. Like here we have a server and we have a concentrator. Now the internet. The internet is a global network of interconnected computer networks that uses standard protocol to enable communication and exchange of information between computers located in different locations around the world. The internet has become an essential part of modern life. It helps us to communicate in work, for example, is used in work, for shop, for fun, for example, and for studying. The internet is made up of a million of servers, routers and switches, and other equipment that interconnect computers around the world. It works through a set of communication protocols such as TCP or IP, HTTP and FTP, which allow computers to communicate with each other computer. The internet is a global network connecting millions of computers. It is a massive network of networks in which any computer can communicate with any other computer as long as they are both connected to the internet and that transmit data using the standard internet protocol IP. Now the intranet. Intranet is a private computer network that uses internet technologies to connect an organization's computers and resources such as employees, departments, applications, and databases. Intranets are often used to facilitate the communications, collaborations, and information sharing within an organization. Unlike the internet, which is a public network accessible to everyone, an intranet is reserved for members of the organization and often requires automatical to access the resource. This is the difference between the intranet and the internet. The intranet is a private network, is used in in a department, or for example university or a school, for example. It's contained within an enterprise. It may consist of many interlinked in a local area networks. Now let's talk about the extranet. Extranet is a private computer network also that is used internet technologies to connect an organization with its business partner and suppliers, customer, or other external devices. Unlike an intranet, which is limited to internet members of an organization, it is therefore an extended network. Extranet can be used to share information, to share files and resources, security. It has the security between the organizations. And extranet also are often used to improve efficiency and communication between the organization. And finally, the extranet is required for normal day-to-day businesses activities. This is the difference between the internet, intranet, and the extranet. Let's see together now the network diagram. Here we have a customer network, the internet, the extranet, and here we have the intranet and the intranet server. The intranet and extranet is used in a company, for example, and it's more secure than internet. Let's talk now about the protocol. What is a protocol? In computing, protocol is a set of rules and standards that defines how data is exchanged and communicated between different systems. It is a common language that allows different computers and equipment to communicate with each other in a standard way and to integrity of the data exchange. The most commonly used protocols in the internet includes the TCP and IP, HTTP, FTP, and DNS, among others. Let's start with the TCP and the IP. An internet protocol address, IP, is a logical numeric address that is assigned to every single computer, printer, switch, router, or any other device that is part of a TCP and IP-based network. An IP address is a logical address that is used to uniquely identify every node of network connected to the internet. IP is a communication protocol that allows you to identify and communicate with the devices on a computer network. Each device on a network has a unique IP address, which is used to route data and from that device on the network. The IP address is a string of numbers that uniquely identifies a device on a computer network. DNS, or the Domain Name System, is a computer system for translating domain name into IP address, and vice versa, to allow users to access online resources. In other words, DNS is a directory of domain names that help located computers or services connected to the internet using easy to remember name rather than complex IP address. This is the DNS and the difference between the DNS and the IP. Now, HTTP, or Hypertext Transfer Protocol, is a communications protocol used to transfer data over the web. It allows a client, such as a web browser, to communicate with a web server to retrieve files, web page, images, and other resources. The HTTP protocol is based on a client server model where the client sends a request to the server for data, and the server responds with the request data. This is the HTTP, or the Hypertext Transfer Protocol. Now the HTTPS, or the Hypertext Transfer Protocol secures, is a communication protocol used to transfer data over the internet. It is similar to HTTP but used in an SSL or TLS transport layer to ensure the confidently and integrity of the transferred data. FTP, or the File Transfer Protocol, is a file transfer protocol widely used on a computer networks for sharing file, upload or download between a server and a client. HTTP is often used to transfer large files such as images, videos, and audio files. This is the importance of the file transfer protocol. What is a number system? A number system, or a system numeration, is a writing system for expression numbers that is a mathematical notation for representing numbers of a given set using digits or other symbols in a consistent manner. For example, in our day, we use the decimal number system. It means we use the numbers between 0 and 9. Now, the number of distinct symbols used in a number system is known as radix or base. So in decimal system, the base is 10 because we count from 0 to 9. We have 10 digits. So let's see now the type of the number system. We have the decimal number system. It's used by the human. It has the base of 10. The binary system is used by the computer or the machines. It has the base 2, 0 and 1. The decimal numbers, the base 10, 0 to 9. The binary base 2, 0 and 1. 0 is indicate true and 1 indicate false. Octal number system and the hexadecimal number system is used by the software, and we have the base. He has the base of 16. This is the type of the number system. Let's start with the decimal number system. The base of the decimal number system is 10. The symbols is 0, 1, 2, 3, 4, 5, 6, 7, 8. Is used in our day-to-day life. Now let's see the binary number system. The base of the binary number system is 2. Symbols is 0 and 1. 0 indicate false and 1 indicate true. Computers and it's used by the computers and digital system, for example, computer, phone, smartwatch. This is how we use the binary number system. The octal number system have the base 8. Symbols is 0, 1, 2, 3, 4, 5, 6, 7. Is used widely in computing system. And finally, the hexadecimal number system. The base of the decimal number system, hexadecimal number system, is 60. The symbols is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, D, E, F, G for Z, A to Z, and 0 to 9. This is the base of the hexadecimal number system. is used in computing system and memory representation. This is all about the number system and the type of the number system. Now let's see the table of the ASCII symbols. We have here the character and the ASCII number. We use this table when we need to convert, for example, a word to a binary or a binary to a word. We need to solve now an example how to convert a word to a binary number and a binary number to a word. Let's solve this question. Convert this binary number to a word. First, we have this binary number 0 and 1. All the binary number is 0 and 1, contains 0 and 1. First, what is the binary number? We have the base of 2 and the symbols is 0 to 9. To convert this number to a word, we start from here, 1. The 1 is, if I need to write 1 in a binary number, it's 2. The 1 here in this number is 2 power 0. We start from here, 2 power 0, 2 power 1, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, and 2 power 8. Now let's write this number. This number is equal to 0, start from here, 0, it's 0, time 2 power 7, it's 1. Okay, this number is 0 time 2 power 7, it's plus, now this second number, this second number is 1 time, because here we have 1 time, it's 2 power 6, 2 power 6, plus, here it's 0, 0, it's 0, 0 time, this is 2 power 5, 32, plus, here this is also 0, it's 0 time 2 power 4, plus, also 0, 0 time 2 power 3, it's 8, plus, also 0 time 2 power 2 is 4, plus 0 time 2 power 1, it's 2, plus 1 time 2 power 0, 2 power 0 is 1, 1 time 1. And we calculate this this question and we have 65. This is the final result, 65, 0, 1, 0, 0, 0, 0, 1. This binary number is equal to 65. We go to the ASCII table and show 65 is A here. And this is the letter A. Now let's go to the second number, and let's start. It's 0 times 2 power 7 plus 1 times 2 power 6 plus also 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3, it's 8, plus 1 times 2 power 2 is 4, plus 0 times 2 power 1 is 2, and finally 1 times 2 power 0 it's 1. And we calculate, and we have 109, and we go to the ASCII table, and 109, this is the letter M, here the small m, here we have the capital A and the small m here. Now let's continue with this number is equal to 0 times 2 power 7, it's 0, plus 1 time 2 power 6 plus 1 times 2 power 5 is 32, plus sorry here, because 1 times 2 power 6, 1 times 2 power 5, now 0 times 2 power 4 is 0, plus 1 times 2 power 3 is 8, plus 0 times 2 power 2 is 0, plus 0 power 2 power 1 is 0, and finally 1 times 2 power 0 is 1. And we have 105, and let's go to the table. Is here I, the small I. Now finally the last binary number is 01010011, and let's start. 0 times 2 power 7 is 0, plus 1 times 2 power 6 is 64, plus 0 times 2 power 5 is 0, plus 1 times 2 power 4 is 16, plus 0 times 2 power 3 is 0, plus 0, 0 times 2 power 2 is 0, plus 1 times 2 power 1 is 2, plus 1. 23, 83. Let's go to the table. Here, the letter S. It's the big S, capital. Okay, A, M, I, S. It's a French. It's a French word, ami. This is how to convert a binary number to a word. Now let's convert a word to a binary number. Cat. Cat. And let's start to convert. And let's start with the C. C is equal to, go to the table, C, where is the C? Big C, 67. C is equal to 67. And 67 is equal to 0 times 2 power 7, it's 0. 1 times 2 power 6, 64. 64, I need 3 also. What is the number that gives me a 3? We have 2 power 1 is 2, and 2 power 0 is 1. 2 plus 1 is 3. 1 time 2 power 2, 2 power 1 is 2, plus 1 time 2 power 0 is 1. And finally, I obtain the number 0, 1, 0, 0, 0, 0, 1, 1. I start with 2 power 7, 2 power 0. Now, get A. A in the table is the small a, 97. Is equal to 0 times 2 power 7, it's 0, plus 1 times 2 power 6, plus 1 times 2 power 5, it's 32, plus 0, plus 0, plus 0, plus 0, and 1 time 2 power 0, it's 1. I obtain here 0, 1, 1, 0, 0, 0, 0, 1. Get T is equal to T, this is the T, is equal to 0 times 2 power 7, 0, plus 1 times 2 power 6 is 4, plus 32, plus 0, plus 1 here. 2 power 2 is 4, plus 0, plus 0. Let's convert him to binary number, and I obtain 0, 1, 1, 1, 0, 1, 0, 0. And finally, the point. We have here a point. In the table, the point is equal to 78. Is equal to 78 is equal to 0 times 2 power 7 plus 1 times 2 power 6 plus 0 plus 0 plus 1 times 2 power 3 is 8 plus 1 times 2 power 2 is 4 plus 1 times 2 power 1 is 1 plus 0 is equal to 0, 1, 0, 0, 1, 1, 1, 0. This is how to convert a word to a binary number. It's very important to use this table. Okay guys, let's start with the number 1. Convert the word hello to binary. Here we have the ASCII table, and here we have the binary is the base of 2. We need to use this 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4 to power 7. Let's start with the H, capital H. This is the H, it's 72. Here, the big H is equal to 72 is equal to. Let's go for here, and what is the two number or the numbers that give me 72? We have 2 power 6, 64 plus 8, 2 power 3. 2 power 6 plus 2 power 3, and let's start to write the H on binary, and let's start with 2 power 7. It's 0 times 2 power 7 plus 0 times or 1 times 2 power 6 plus 0 times 2 power 5 plus 0 times 2 power 4 plus 0 times or 1 times 2 power 3, 8 plus 0 times 2 power 2 is 4 and plus 0 times 2 power 1 and finally 0 times 2 power 0. So H is equal to here 0, 1, here 0, 0, 1 and 0, 0, 0. This is H in binary. Now the E. The small e here 101. Now let's go to here and to calculate what is the numbers that give me 101, and let's see. We have 2 power 6 plus 2 power 5 and 2 power 2, it's 100, and 2 power 0, it's 101. Let's start to write this number on binary, and let's start with 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 plus 0 times 2 power 1 and finally 1 times 2 power 0, it's 1. And let's write the binary number here 0, 1, 1, 0, 0, 1, 0, 1. This is the letter E in binary. We have now the double L. L in decimal, it's equal to the small l, here 108. And let's go to here to search what is the numbers that give me 108. And let's start to calculate, and we have 2 power 6 plus 2 power 5 and 2 power 3 plus 2 power 4. 64 plus 32 plus 8 plus 4 is equal to 108. And let's write this on binary. And 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 and plus 1 times 2 power 2, 0 times 2 power 1, and finally 0 times 2 power 0. And let's write this on binary. 0 1 1 0 1 1 0 0. This is L on binary. We have double L, we need to put this 2 times. And finally O. O in decimal is equal to 111. Let's calculate what is the numbers that give me 111. We have 2 power 6, 2 power 5, plus 2 power 4, and 2 power 3 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. Okay, we have 64, 64 plus 32 plus 8 plus 4 plus 2 plus 1. This is the numbers that give me 111, and let's start here. And 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4, it's 0, plus 0 times or 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. And let's write this on binary. It's 0 1 1 1 0 1 1 1 1. And this is the number on binary. Now let's write the word hello in binary. And finally, this is the word hello in binary. Okay guys, now let's convert the word coding to binary. And let's start with the C. The small c is equal to 99. C is equal to 99. And let's go to search what is the numbers that give me 99. Let's start with 64 plus 16. It's 18 plus 8, or we can put okay, the numbers that give me 99 is 2 power 6, 64, plus 2 power 5, 32, plus 2 power 1 is 2, and 2 power 0 is 1. 64 plus 32 plus 2 plus 1 give me 99, and let's start to write this on binary. 0 times 2 power 7 is 0, plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 0 times 2 power 2 plus 1 times 2 power 1 is 2 plus 1 times 1 is 2 2 power 0. And let's write this on binary, and we have 0, 1, 1, 0, 0, 0, 1, 1. Now, O, the small o, it's 1, 1, 1, and it's O is equal to 1, 1, 1. I solved the O in exercise number 1, and is equal to 0, 1, 1, 0, 1, 1, 1, 1. This is O in binary. Coding the D. D is equal to 100. D and the numbers that give me 100 is 64 plus 32 plus 4 equal 100. Let's write this on binary, and D is equal to 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 plus 0 plus 0. And let's write this on binary. And this is the D on binary. Now the I. I is equal to 105. And let's calculate the numbers that give me 105. We have 64 plus 32 plus 8 plus 1. It's 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 0 plus 0 plus 0 is equal to 0, 1, 1, 0, 1, 0, 0, 0. This is I on binary. Now the N. n is equal to 110. Let's calculate the number that give me 110. It's 64 plus 32 plus 8 plus 4 plus 2. And it's 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 and 0 times 2 power 0 is equal to 0, 1, 1, 0, 1, 1, 1, 0. And this is n on binary. And finally G. G is equal to 103. And is equal to 64 plus 32 plus 4 plus 2 plus 1. And it's 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0 is equal to 0, 1, 1, 0, 0, 1, 1, 1. This is G on binary. And finally, this is coding coding from the word to binary. Now let's convert the word by to binary. Let's start with B is equal to by B 98 is equal to, let's calculate the numbers that give me 98. And we have 64 plus 32 plus 2 is equal to 98. And it's 0 times 2 power 7 plus 1 times 2 power 6 plus 2 times 1 times 2 power 5, 0 times 2 power 4, 0 times 2 power 3, 0 times 1 times 2 power 2, and 0 times 2 power 1, and 0 times 2 power 2, and this is B on binary. Y is equal to Y 121. It's 64 plus 32 plus 16 plus 8 plus 1. And let's convert this to binary. It's 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 and 1 times 2 power 4, 8, 1 times 2 power 3, 0 times 2 power 2, 0 times 2 power 1, and 1 times 2 power 0. And this is Y on binary. Now E. I calculate E in exercise 1, and it's equal to 101, it's equal to 0 times 2 power 7, 1 times 2 power 6, 1 times 2 power 5, 0 times 2 power 4, 0 times 2 power 3, 1 times 2 power 2, 0 times 2 power 1, and 1 times 2 power 0, and this is E on binary. This is the word bi on binary. Now let's convert the word cat to binary, and let's start with C. C is equal to 99. C is 0 times 2 power 7 plus 1 times 2 power 6 plus 1 time 2 times 2 power 5 plus 0 times 2 power 4, 0 times 2 power 3, 0 times 2 power 2, plus 1 times 2 power 1, and 1 times 2 power 0. This is C. A is equal to 97 is equal to 0 times 2 power 7, 1 times 2 power 6, 1 times 2 power 5, 0 times 2 power 4, 0 times 2 power 3, 0 times 2 power 2, 0 times 2 power 1, and 1 times 2 power 0. And the T equal to 116 is equal to 0 times 2 power 7, 1 times 2 power 6, 1 times 2 power 5, 1 times 2 power 4, 0 times 2 power 3, 1 times 2 power 2, 0 times 2 power 1, and finally 0 times 2 power 0. And this is T on binary, and this is the word cat on binary. Now let's convert this binary number to a decimal number. This number is equal to, we start from here, this is 0 times 2 power 7, 2 power 7, plus is equal to 0, plus here we have 1 times 2 power 6, it's 1 times 64, plus 0 times 2 power 5, plus 0 times 2 power 4, plus 0 times 2 power 3, plus 0 times 2 power 2, plus 0 times 2 power 1, and finally 1 times 2 power 0 is equal to 1. And this number is equal to 64 plus 1 equal to 65. And let's go to the table and search for 65 is equal to the capital A. Zero times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 0 times 2 power 2 plus 1 time 2 power 1 plus 0 times 2 power 0 is equal to 64 plus 32 plus 2 is equal to 98. 98, let's go to the table. 98 is the small b. Now let's convert this number. And let's start with 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2 plus 0 times 2 power 1 plus 0 times 2 power 0 is equal to 64 plus 32 plus 8 plus 4 is equal to 108, and it's the letter 108, letter L, the small l. And this is how to convert the binary to decimal. And it's equal to 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 and 1 times 2 power 0 is equal to 64 plus 32 plus 8 plus 4 plus 2 plus 1 is equal to 111. And let's go to the table. It's the letter O, the small o. Now let's convert this number. And it's 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 1 times 2 power 4 plus 0 times 2 power 3 plus 0 times 2 power 2 plus 1 times 2 power 1 and 0 times 2 power 0, and is equal to 64 plus 32 plus 16 plus 2 is equal to 114, and it's the letter small r. Now let's convert this number. Is equal to 0 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 is 4 and 0 times 2 power 1 and 0 times 2 power 0 is equal to 64 plus 32 plus 4 is equal to 100, and it's the letter D. And this number is equal to 0 times 1 times 2 0 plus 1 times 2 power 6 64 plus 0 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0 is equal to 64 plus 8 plus 4 plus 2 plus 1, 79, It's 79. It's the big O. Now this number is equal to 0 plus 64 plus 0 plus 16 plus 0 plus 4 plus 2 plus 0 is equal to 26. It's V. Now this number also is equal to 0 plus 64 plus 32 plus 0 plus 8 plus 0 plus 0 plus 1 is equal to 105, and it's the letter E, I. And finally, let's make this number, and now we need to convert the decimal number 49 into hexadecimal. First, we need to remember that the hexadecimal, we have it's the base of 16. So to convert this decimal number to hexadecimal number, we need to divide 49 by 16. Divided by 16, it's 49 divided by 16. We have the quotient is equal to 3, and remainder is equal to 1. And finally, the hexa value is 1. We make another division. We divide 3 divided by 16. 3 by 16. The quotient is equal to 0. And the remainder is 3. And the hexadecimal value is equal to 3. Okay, and finally, 49 in decimal is equal to 31 in hexadecimal. And now let's convert this number to hexadecimal. First, we need to divide it by 16. That gives me a quotient equal to 76. 76. Remainder equal to 12. And the hexadecimal value is C. In hexadecimal, we have the numbers 0 to 9, and we start 9. A, B, C. C is 12 in hexadecimal. Now we divide also 76 divided by 16. We have the quotient equal to 4. Remainder is equal to 12 also. Also, this is the C. 0, 9, 10 A, 11 B, and 12 C. Now also 4 divided by 16 have 0, and remainder is equal to 4, and 4 is 4 in hexadecimal. And finally, this number is equal to 4 cc in hexadecimal. And now let's convert the number 600 to hexadecimal. And first let's divide it by 16. We have the quotient is equal to 37, remainder is equal to 8, and the hexadecimal value is 8. Now we divide 37 by 16. We have the quotient is equal to 2, remainder is equal to 5, and the hexadecimal value is 5. And now let's divide the number 2 by 16. That gives me 0, and the remainder is equal to 2. And 2 in hexadecimal is 2. And finally, 600 in hexadecimal is equal to 258. Now let's convert the numbers 32 to hexadecimal. And let's start with 32 divided by 16 is equal to 2, and the remainder is equal to 0. In hexadecimal it's 0. And now 2 divided by 16, quotient is 0, and the remainder is 2. And in hexadecimal 2 is equal to 2. And finally 32 is equal to 20 and hexadecimal. Now let's convert the number 100, and first 100 we make the division 100 divided by 16. The quotient is equal to 6, and the remainder is equal to 4. Now let's make 6 divided by 16. Have the quotient equal to 0, and the remainder is equal to 6. In hexadecimal 4 is 4, and 6 is 6 also. In hexadecimal 100 is equal to 64. Now let's convert 255 into hexadecimal. Like the other exercise, it divided by 16. It gives me a quotient is equal to 15. The remainder is equal to 15 also. In hexadecimal 15 is equal to F. Now let's make 15 divided by 16. It's 0. And here 15 also is equal to F in hexadecimal. Is equal to F. Now let's make the division to show how to convert the number 125 to hexadecimal. I need to divide this number by 16, and here 125. First, 125 divided by 16 is equal to 7. 7 times 16 is equal to 112 minus, here we have 13. Now we have 7, the remainder, and 13. 7 is the quotient and 13 is the remainder. 13 is equal to D in hexadecimal. And finally, 125 is equal to 7D. And now let's make the division also to convert the decimal number 125 to binary. Here we don't divide this by 16 because in binary the base is 2. Let's make the division. Here we have 2 and here we have 125. And 125 divided by 2 is 62. 62 times 2 is 124. Here minus, and here is 1. Now this number 62 is divided by 2. Here we have 31 and 62. 31 times 2 is 62. Here we have 0. Now 31 is divided by 2 also. It's 15 times 2 is equal to 30. 31 minus 13 is equal to 1. And now 15 is divided by 2 also. It's 7. 7 times 2 is 14. 15 minus 14 is equal to 1. Now 7 times 2 is 3. 3 times 2 is 6. 7 minus 6 is 1. And 3 times 2 is 1. 1 times 2 is 2. 3 minus 2 is 1. And finally, we obtain these numbers. And in binary, 125 is equal to 1111101. Now let's convert this hexadecimal number to decimal number. 77D is equal to, here we have the base of 16 because we work with the hexadecimal number. We'll start with D. D times, like the binary number, 16 power 0 plus 7 times 16 power 1 and it's equal to 13 times 1 plus 7 times 16 is equal to 125. This is how to convert from hexadecimal to decimal. Now let's convert 70 to binary. Here we have 7d is equal to 7 plus 13. In binary, what is the number that gives me 7? It's 4 plus 2 plus 1. It's 0 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. This is the 7. Now the d, or 13, is equal to 1 times 2 power 3 plus 1 times 2 power 2 plus 0 times 2 power 1 plus 1 times 2 power 0. And in binary, 7d is equal to 0, 1, 1, 1, and 1, 1, 0, 1. This is the 7, and this is the d. Now let's convert 4095 to hexadecimal. And first let's divide this number by 16. The quotient is equal to, and the remainder is equal to 15. 15 is f. Now the quotient is divided by 16. 16. The remainder is the quotient is 15, and the remainder is 15 also. And 15 in hexadecimal is f. And now 15 times 16 is 0. The remainder is 15 also. And in hexadecimal, it's equal to f. This number in hexadecimal is equal to FFF. Now let's convert this number to hexadecimal. And let's start with, we need to divide this number by 16. The quotient is 77, and the remainder is 2. In hexadecimal, 2 is 2. Now 77 divided by 16, the quotient is equal to 4. Remainder is equal to 13, and in hexadecimal it's equal to d. Now 4 divided by 16 is equal to 0. The remainder is 4, and in hexadecimal it's 4 is equal to 42. Now let's convert the number 678 to hexadecimal, and let's divide this number by 16. 42 remainder is equal to 6, and in binary hexadecimal 6 is 6. Now let's divide 42 divided by 16. The quotient is 2, remainder is 10. 10 in hexadecimal is A. Now 2 divided by 16, the quotient is 0, and the remainder is 2, and 2 in hexadecimal is 2. In hexadecimal 678 is equal to 2A6. Now let's convert the octal number to decimal number 25. 25 is equal to, here like the binary, for example, in binary we put 0 times 2 power 0, for example. Here the octal is the base of 8. We calculate like this. It's 2, here 25, it's 2 times 8 power 1 plus 5 times 8 power 0. Like this, we convert the octal number to decimal. It's equal to 2 times 8 plus 5 times 1 is equal to 16 plus 5, it is 21. This is how to convert an octal to decimal with a base of 8. Now let's convert 137 to decimal is equal to 1 times 8 power 2 plus 3 times 8 power 1 plus 7 times 8 power 0 is equal to 64 plus 24 plus 7 is equal to 95. This is the number 137 in decimal. Now let's make the number 456 is equal to 4 times 8 power 2 plus 5 times 8 power 1 plus 6 times 8 power 0 is equal to 302. Now 302 to decimal is equal to 3 times 8 power 2 plus 0 times 8 power 1 plus 2 times 8 power 0 is equal to 194. Now the number 777 is equal to 7 times 8 power 2 plus 7 times 8 power 1 and 7 times 8 power 7 is equal to 511. Let's continue with this number also. Is equal to 1 times 8 power 3 plus 2 times 8 power 2 plus 3 times 8 power 1 plus 4 times 8 power 0 is equal to, with the calculator, give me this number is equal to 668. Now the number 312 is equal to 3 times 8 power 2 plus 1 times 8 power 1 plus 2 times 8 power 0 is equal to 202. Now the number 5500 it's 5 times 8 power 2 plus 0 times 8 power 1 plus 0 times 1 is equal to 320. Now the number 146 is equal to 1 times 8 power 2 plus 4 times 8 power 1 plus 6 times 8 power 0 is equal to 102. Now 7023 is equal to 7 times 8 power 2 plus 2 times 8 power 1 plus 3 times 8 power 0 is equal to 467. And finally 1000 is equal to 1 times 8 power 3 plus 0 plus 0 plus 0, it's equal to 512. This is how to convert the octal number to a decimal number. Convert the hexadecimal to decimal, and let's start with 1A. 1A, here the hexadecimal is the base of 16. It's 1 times 16 power 1 plus 8 times 16 power 0. It's equal to 1 times 16 plus A, it's 10 in decimal, times 1 is equal to 16 times plus 10, it's 26. Now let's convert 2f is equal to 2 times 16 power 1 plus f times 16 power 0. It's equal to 32 plus 15. It's equal to 47. Now 3b it's a 3 times 16 power 1 plus b times 16 power 0. It's 48 plus 11. It's equal to 59. 4c is equal to 4 times 16 power 1 plus c times 16 power 0. It's equal to 64 plus 12. It's equal to 76. Now the 7e is equal to 7 times 16 power 1 plus e times 16 power 0. It's equal to 112 plus in decimal e equal to 14. It's 14. It's equal to 126. A3 is equal to a in hexadecimal is equal to 10 times 16 power 1 plus 3 times 16 power 0. It's equal to 116 plus 3 equal to 163. B7 is equal to B is 11 times 16 power 1 plus 7 times 16 times 16 power 0 is equal to 183. D9 is equal to D is 13 times 16 power 1 plus 9 times 16 power 0 is equal to 217. F4 is equal to F in decimal is 15 times 16 power 1 plus 4 times 16 power 0 is equal to 500. And finally 1F4 is equal to 1 times 16 power 2 plus 15 times 16 power 1 and 4 times 16 power 0 is equal to 500, and here it's not 500, it's 244. And this is how to convert an hexadecimal to a decimal number. Now let's convert octal number to an hexadecimal number. The number is 137. 137 is equal to 1 time 8 power 2 plus 3 times 8 power 1 plus 7 times 8 power 0 is equal to 64 plus 24 plus 7 is equal to 95. Now let's divide number 95 divided by 16 is equal to 5. Remainder 15. 15 in hexadecimal is F. Let's divide 5 times 16. It's 0. Remainder 5. In hexadecimal, this number is equal to 5F. 137 is equal to 5F in hexadecimal. Now let's convert octal to binary. This number. Binary to octal, this number. Let's take 3 number. Look how. For example, this first 3 number 0, 1, 1, and next number is 0, 0, 1, and finally 0, 1, 1. Let's start with the first number. It's equal to 3. It's 1 time 2 power 0 plus 1 time 2 power 2. 2 power 1. It's 1 plus 2 plus 0 is equal to 3. And this number is equal to 1. And this, like the first, is equal to 3. This number in octal is equal to 313. This is how to convert a binary to octal and the octal to hexadecimal. Now let's convert the following binary number to an octal, decimal, and hexadecimal form. Let's start to octal. It's equal to 735. How we put 3 number, and we calculate to obtain the number 735. Now to decimal. We have 1 time 2 power 8 plus 1 time 2 power 7 plus 1 time 2 power 6 plus 1 time 2 power 4 plus 1 time 2 power 3 plus 1 time 2 power 2 plus 1 time 2 power 0 is equal to 477. And finally to hexadecimal. It's we have 001, 1101, and 1101. It's equal to, here the first is D, and this is also D, and this is 1. It's 1. Here DA equal to 10, 11, 13. It's 13. 13 in hexadecimal is D. D. Now let's convert also this number to octal, decimal, and hexadecimal, and let's start with the octal. In octal, it's equal to 2527. In decimal is equal to 1 times 2 power 10 plus 1 times 2 power 8 plus 1 times 2 power 6 plus 1 times 2 power 4 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. It's equal to 103,067. And finally to hexadecimal. It's equal to 0101, 0101, and 0111. 0101 is equal to 5 and 5, and 0111 is equal to 7. This is how to convert this number to octal, decimal, and hexadecimal format. And finally, let's convert this number to octal, decimal, and hexadecimal. And in octal, it's equal to 714. In decimal, it's equal to 1 times 2 power 8 plus 1 times 2 power 7 plus 1 times 2 power 6 plus 1 times 2 power 5. It's equal to 418. To hexadecimal, it's equal to 1E 0. Now let's convert this following octal to decimal and hexadecimal format. In decimal, the base of 8, it's 3 times 8 power 3 plus 7 times 8 power 2 plus 5 times 8 power 1 plus 4 times 8 power 0, it's 4. And it's equal to 2028. Now in hexadecimal, it's 0111, 1110, 1100, and it's equal to 7 EC. Now let's convert this number, octal number, to decimal and hexadecimal. In decimal, it's 7 times 8 power 3 plus 7 times 8 power 2 plus 7 times 8 power 1 plus 7 times 8 power 0. It's equal to 4095. Now, to hexadecimal, it's 1111, 1111, and 1111. It's equal to FFF. It's 15. Name at least 5 basic components of a computer system and briefly describe their functions. In our computer, we have the CPU, it's the brain of the computer. We have the random access memory, or the RAM and ROM. We have the hard disk, the motherboard. The motherboard, it held the component to communicate between them. And finally, the power supply. Let's see the solution. The central processing unit, or the CPU, it executes instructions from software and coordinates the activities of all other hardware components. The random access memory, or RAM, temporarily stores data and instructions that the CPU needs while performing tasks. The hard drive, it stores data and applications. The motherboard is a circuit board that connects all the components of the computer and allows them to communicate between them. Finally, the power supply unit, or PSU, it provides power to all components of the computer. This is the solution of the first exercise. 2. What is the operating system, and give 2 examples of operating system. The operating system acts as an interface between the software and different parts of the computer, or the computer hardware. In our life, we know 2 operating systems, the Microsoft and Linux. Let's see the solution. An operating system, OS, is a software that manages computer hardware and software resources and provides common service of computer programs. Example of the operating system, we have the Windows 10 and the Mac OS. And the Linux also is an operating system. Number 3, match the following file extensions with their corresponding file type. docx, it's a Word document. GPG, it's an image file. MP3, it's an audio file. PDF, it's a portable document format. And XLSX, it's an Excel. And this is the solution. Now exercise 4. What are the keyboard shortcuts for the following action in most Windows operating system? Copy. To copy, for example, a text, we put Ctrl C. To paste, Ctrl V. To cut, for example, a text, a word, an image, we use Ctrl X, and to undo, we use Ctrl Z. And this is the solution. Copy, Ctrl plus C, paste, Ctrl plus V, cut, Ctrl plus X, and undo, Ctrl plus Z. Exercise number 5. Name 3 popular internet browsers. Internet browsers like Google, Chrome, Firefox, Microsoft Edge, Safari, etc. This is the internet browser that we know. 6. What is the difference between the internet and the internet? The internet is a private network, but the internet is a global network of interconnected computers that communicate freely. This is the difference between them. Internet is a global network of interconnected computers that communicate freely. The intranet is a private network accessible only to an organization's staff. This is the difference between the internet and the intranet. Now the difference between the system software and application software with an example for each other. Let's start with the system software. The system software, like the Windows OS, it's a software designed to provide a platform. But the application software, like the Microsoft Word, it's a software designed to help the user to perform her specific tasks, for example, to make a search, to communicate with someone, etc. System software is a software designed to provide a platform for other software, for example, Windows. And application software is a software designed to help the user perform specific tasks, like the Microsoft Word, Microsoft PowerPoint, Microsoft Edge, and other components. In number 8, we need to arrange the following data storage units in ascending order of size. Let's start. We have the kilobyte, megabyte, gigabyte, and terabyte. Number 9, list 3 practices to ensure safe computing. Safe computing, we have use strong, unique password and change the password, for example, each month, each week. Install and update the antivirus software, and finally, back up your information. This is the 3 tips to ensure the safe computing. Change the password, for example, each week, each month. Install and update the antivirus, and back up your data and the information. Number 10, describe 2 basic computer maintenance tasks to keep a computer running smoothly. We have the disk cleanup. It's removing unnecessary files to free up space to the hard drive. And second, the software updates, regularly updating the operating system and applications to ensure they have the last security patch and features. This is the 2 basic computer maintenance tasks to keep the computer running smoothly. 7. List of the main components of a desktop computer and briefly describe their functions. In a desktop computer, we have the motherboard. It's a circuit board that contains the CPU, the RAM, storage, etc. It's not contain the storage, but it helps the computer to work. Second, we have the CPU. The CPU is the brain of the computer, and it's the most important component of a computer. We have the GPU. GPU is the graphic processing unit. We have the storage, HDD and SSD. We have the power supply unit, the cooling system, optical drive, the peripheral interface like the USB port, audio jack. It helps to connect a component to our computers. And finally, we have the case. Let's see the solution of this exercise. We start with the motherboard, the main circuit board that house all the CPU, RAM, and other essential components. CPU is the brain of the computer that performs instructions defined by the software. RAM, or random access memory, temporary storage that hold data and instructions for quick access to the CPU. GPU, graphic processing unit, it handles rendering of images, video, and animations. Storage, HDD or SSD, it stores all the data, the software, and the operating system. Power supply unit, it converts electricity from the outlet into usable power of the computer's components. Cooling system, prevent the computer from other heating, including the fans and the heat sinks. Optical drive, read and write the data from CD, DVD, Blu-rays. The peripheral interface, USB port, audio jacks, for connecting the external devices. Finally, the case, it encloses and protects all the internal components. This is what contains the desktop of the computer. Now exercise number 12. We need to explain the role of the CPU on the motherboard. The CPU on the central processing unit, it's a primary component responsible for executing instruction and processing the data in a computer. This is the role of the CPU. The CPU is the brain of the computer and it's the most important component of a computer. The CPU, or the central processing unit, is a primary component responsible for executing instructions and processing data in a computer. It performs the basic arithmetic and logical control and input-output operations specified by the instructions in the computer program. This is the importance of the CPU on the motherboard. Let's go to the exercise number 13 and describe the function of the RAM in a desktop computer. First, the RAM is a volatile memory that stores data and instruction that the CPU needs while performing tasks. It allows for quick read and write access to a storage medium that is faster than traditional storage options. This is the function of the RAM on a desktop computer. Number 14. What is a computer network? A computer network is a collection of interconnected devices that are communicate and share resources such as data, file, like printer, internet connection. It can be a million of a computer that are connected between them to share data, to share information, image. For example, in a department, we have, for example, 10 computers. This computer is communicate between them. For example, if I need to print something, I connect my computer to the printer. This is the importance of the computer network. A computer network is a collection of interconnected devices that can communicate and share resources such as data files, printers, and internet connections. These devices communicate using a set of protocols over wired or wireless connection. Exercise number 15. What is the difference between a LAN and WAN. LAN is a local area network, is a network that converts a small geographic area, but the WAN is a wide area network. It converts a large geographic area. This is the difference between them. LAN, or local area network, is a network that converts a small geographic area, such as a single building or a campus. It is typically used to connect computers and devices with a localized area for resource sharing and communication. WAN, or wide area network, it converts a large geographic area, often spanning cities, countries, or even continents. It connects multiple LAN together, usually through public network like the internet or leased line. This is the difference between the local area network and the wide area network. Exercise 16. Explain the role of the router in a network. The router are an essential for communication between a device on a different networks, including between a home network, for example, and the internet. Let's see the solution. A router is a networking device that forwards data packets between computer networks. It connects different networks, directing the data to its intended IP address and ensuring that information reaches the correct destination. The routers are an essential for enabling communication between the device on a different networks, including between a home network and the internet. This is the role of a router. Now let's describe what an IP address is. IP address, IP, it's an internet protocol address, is a unique identifier assigned to each device connected to a network. The Internet Protocol address is a unique identifier assigned to each device connected to a network. It serves two main purposes: identifying the host or the network interface and providing the location of the host in the network. This is the importance of the IP address. 18. Explain the function of the DNS server. What is a DNS? DNS is the domain name system server. It translates human readable domain name into IP address that computers use to identify each other on the network. DNS servers allow users to access websites and other resources using easily memorable names instead of numerical IP address. Now explain the concept of the network topology and name three common types. What is the network topology? A network topology defines the layout and the structure of the network and how the construction are communicated between them. We have three common types: bus topology, ring topology, and star topology. Network topology refers to the arrangement of different elements, links, nodes, etc. in a computer network. It defines the layout and structure of the network, determining how devices are interconnected and communicate with each other. we have three common types of a network topology. One, bus topology. In the bus topology, all the devices are connected to a single central cable called the bus. Data sent by one device is available to all other devices on the network. Two, star topology. In the star topology, all the devices are connected to a central hub or switch. Data is sent from one device to the hub, which then forwarded to the destination device. Three, ring topology. In the ring topology, devices are connected in a circular fashion, with each device connected to two other devices. Data travels in one direction around the ring until it reaches its destination. This is the network topology and the three common types of the network topology. 18. Define the term application software. Application software is an application that can be installed on a computer or on our phone. It helps us to make a search, for example. It can be a game, an application like the Facebook, WhatsApp, etc. This is the application software. Application software refers to a programs designed for end users to perform specific tasks such as word processing, web browsing, or gaming. What is the function of a web browser? Web browser is a software used to access and view websites on the internet. For example, include Chrome, Safari, and the Firefox. This is the function of the web browser. Now, what is the difference between the system software and the application software? The system software, it includes the operating system, for example, Windows, Linux, Mac OS, for example. But the application software, it includes the application on the operating system, like the Microsoft Word, Microsoft Excel, Microsoft PowerPoint. The system software includes the operating system and the managed computer resources, while the application software is designed to help users perform the specific tasks. Now, exercise 21, explain the difference between the Wi-Fi and the Ethernet. Wi-Fi is a wireless network technology. It allows the devices to connect to a network without cable. The Ethernet is a wired networking technology that uses cable to connect device to a network. Okay, the Wi-Fi help the device to connect without cables, but the Ethernet, it allows the device to connect to the network using a cable. This is the difference between the Wi-Fi and the Ethernet. 22. Define database. What is database? Database is like tables that help the user to store their data and informations. Let's see the solution. And the database is an organized collection of data typically stored and accessed electronical form from a computer system. It allows for the efficient and it helps to manage the data. Exercise 23. What is a database management system? DBMS. The DBMS interface for user is a software that provides an interface for users and applications to interface with the database. It helps manage data, the database engine, and the database schema to facilitate the organization and manipulate of data. This is the importance of the DBMS. Exercise 24 explains the concept of the relational database. A relational database is a type of database that stores data in tables which are related to each other through common files. It uses the structured query language SQL. SQL is a magic language for the database. Now, what is a table in database? A database is a collection of related data organized into row and column within a database. Each row represents a record and each column represents a file or attribute of the data. The table in database, it helps us to put our data and information that can be clearly. For example, we can put, if I have a library, we can make a table to put the name of the book and the price. Now exercise 23, define the term primary key in the context of database. The primary key is a unique identifier for a record in a database. It ensures that each record is distinct and can be referenced uniquely. This is the importance of the primary key in database. Now, what is a foreign key? A foreign key is a file in one table that uniquely identifies a row of another table. It is used to establish and enforce a link between the data in two tables. This is the difference between the primary key and the foreign key. '28. Explain what a database schema is. Database schema is the structure that defines the organization of a data within a database. It includes table, relationship, view, index, and other elements that make up the database. Now, what is the SQL? SQL, or the Structured Query Language, is a standard programming language used to manage and manipulate relational database. It is used to query, updating, and managing data. This is the importance of the SQL, and the SQL is the most important language in the database. '30. What is a database index? A database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional storage space and maintenance. Indexes are used to quickly locate and access the data without having to search every. This is the database index. 31. Name 3 types of secondary storage devices. We have the hard disk drive HDD, solid state drive SSD, and the USB flash drive. Now, name Two common file systems used in operating system. We have the NTFS, or the New Technology File System. It's common use in Windows. But the ext4 is the fourth extended file system. It's used in the Linux. Windows and Linux are an operating system. Why regular data backup? It's important. We make the backup of our data to protect our data. Regular data backup is important to protect against data loss due to the hardware failure, accidental deletion, malware, or other unforeseen events. It ensures the data can be recovered and operations can continue with minimal disruption. The backup is very important to our phones and our computers. 34. What is cloud storage, and name two popular cloud storage providers. A cloud storage is a service model in which data is maintained, managed, and backed up remotely, and made available to users over the internet. The popular cloud storage providers is Google Drive and Dropbox. What are the primary functions of the following Internet protocol: HTTP, HTTPS, and FTP? HTTP, it's the Hypertext Transfer Protocol, is used for transferring web page on the Internet. The HTTPS is the Hypertext Transfer Protocol Secure. It's an extension of the HTTP and provides secure communication over a computer network. Now, what is the FTP? It's the File Transfer Protocol. Is used to transferring files between a client and a server on a computer network. (36) What is the primary purpose of encryption in ICT? Encryption is used to protect data by converting it into a code to prevent the access. It ensures confidently and data integrity during the storage and transmission. This is the importance of the encryption in ICT. Now the difference between the RAM and ROM. The RAM, it's a random access memory. It's a volatile memory. Is used to store data temporarily while the computer is on. It allows to quick read and write access to a storage medium. But the ROM, read-only memory, it's a non-volatile memory that permanently stores fireware and system software that is not meant to be modified frequently. This is the difference between RAM and ROM. 37. Describe the main difference between HDD and SSD. The HDD, the hard disk drive, is used spinning magnetic disks to read and write data. It typically has a large storage capacity but a slower access speed. But the solid-state drive, the SSD, is used a flash memory to store data. It has a faster access speed, lower latency, and no moving parts, making it more durable and efficient. This is the difference between the HDD and the SSD. Now, name 3 common peripheral devices and their functions. We have the keyboard. It's an input device used to type data into the computer. The mouse is an input device also is used to point, click, and interact with the computer's graphical user interface. The monitor is an output device that displays the visual information from the computer. Now 39. What is the power supply unit important in a computer? The importance of the power supply. The power supply converts the electrical power from an outlet into usable power for the internal component of the computer. It supplies power to the motherboard, CPU, RAM, and other components, ensuring the computer operates correctly. The CPU is very important to our to our computer. What is the purpose of the GPU in our computer? The GPU of the graphic processing unit is responsible of rendering image, animations, and video for the computer's display. It offloads these tasks from the CPU, allowing for better performance in graphics-intensive applications like gaming, video editing, and 3D rendering. This is the importance of the graphic processing unit. Now, 41. What is the function of a network interface card, NIC? A NIC, or the network interface card, allows a computer to connect to a network. It provides the hardware interface for a network connection, enabling the computer to communicate with other devices over a local network or the internet. This is the importance of the network interface card. Now list and describe 3 different types of a software. We have a system software, includes operating system like the Windows, Linux, and Mac OS, and its utility programs that manage computer hardware and provide a platform for running application software. To the application software, programs designed to perform specific tasks for users such as the word processor, like the Microsoft Word, and the web browser like the Google Chrome, and media player like the VLC media player. And 3, the development software. It's a tool and environment for developing software, including the programming language like the Python and Java, compilers, and integrates development like the Visual Studio and Eclipse. Now 43. What is the difference between freeware and shareware? Freeware is a software that is completely free to use without a cost, but the shareware is a software that is used on a trial basis. Users are encouraged to try the software and pay. The user pay for this software to, for example, to communicate with someone, to share information, and etc. The freeware is free without any cost, but the shareware we need to pay to the software. Now a list and describe 3 different files types commonly found on a computer. We have the document files. This includes the text file, word processing file, and speech sheet. We have the image file. This includes various formats like the GPG, PNG, and GIF. We have the executable file. These are files that run programs such as the exe on a Windows and the sh on the Unix and Linux. This is the file type found in our computer. 45. Explain the stored program concept in the von Neumann architecture. The stored program concept states that the instructions for a program are stored in the computer's memory along with the data. This allows the CPU to execute instructions and facilitating easier reprogramming and flexibility. This is the stored program concept in the von Neumann architecture. Now, what is the role of the bus system in the von Neumann architecture? Bus system is a communication pathway that connects the CPU, memory, and input-output devices. It allows data, instructions, and control signals to be transferred between these components. Now explain the role of the control unit and the arithmetic logic unit in the CPU. The CU or the control unit, it interprets the instructions in the memory and causes them be executed. But the arithmetic logic unit, it performs mathematical operation and the logic operation in the CPU. It's like a calculator. Control unit directs the operation of the processor, controlling the fetching, decoding, and execution. It manages the flow of data within the CPU and between the CPU and the memory. Arithmetic logic unit performs arithmetic like the addition, multiplication, and the logic like and or not operations on data. Now compare the von Neumann architecture and the hardware architecture. Von Neumann architecture is used a single memory space for both instructions of data. Its instructions and data share the same bus, causing the von Neumann bottleneck. The hardware architecture uses separate memory space on instruction and data and separate the bus of instruction and data. This is the difference between the von Neumann architecture and the hardware architecture, but in our computers today we use the von Neumann architecture. Now, what is the primary key? A primary key is a unique identifier for a record in a database table. It ensures that each record can be uniquely identified. A table can have only one primary key and it can consist of one multiple column. Finally, what are the types of relationship between a table? We have three types: one-to-one, one-to-many, and many-to-many. One-to-one relationship, each record in table A corresponds to exactly one record in table B and vice versa. And one-to-many is a single record in a table A can be associated with multiple records in table B, but each record in table B is associated with only one record in table A. Many-to-many, multiple records in table A can be associated with multiple records in table B. This type relationship typically requires a junction or associative table. This is the three types of relationships between the tables.